12A on page 440 in your book, Hooke's Law. If a mass of 0.55 kilograms attached to a vertical spring stretches the spring 2 centimeters from its original equilibrium position, what's the spring constant? So we're given mass, deformation, we're looking for K. So mass equals 0.55 kilograms. We know that gravity is acting on the spring, and we're given X, 2 centimeters, so 0.02 meters. Okay. Negative 0.020 meters. Keep your sig figs honest. Okay, so what we know here is that there are two forces acting on the spring system. There's the elastic force, which is pulling it in what direction? Up. Gravity is pulling it down. So we have a net force of the elastic force plus the force of gravity. And we know that the force of gravity is going to be mass gravity. We know that this is going to be negative kx. Okay. So we know that those two are equal to 0. Because the spring ends up at equilibrium. So therefore, kx equals mg. Okay. Net force never goes away. So therefore, K equals mg divided by x.
And look, we have those three variables.
And look, that's what we have. That's convenient.
What was it?
So 0.55 kilograms times negative 9.81 meters per second squared divided by negative 0.020 meters. Let's check out the units here.
Why does the book say it's negative mg over x?
Oh, because because they're using the negative gravity. They're using negative g versus just using g and putting in the negative sign.
Oh.
Let's make sure that it works, but I believe that it will. Yeah, because they're using g as 9.81 meters per second squared, and I'm using it as negative 9.81. So, all right. And if we do the math, give me a raw number. What is it? Give me a raw number.
269.775.
269.775. What are our units?
Awesomeness.
Kilograms times meters over second squared. Wait. Kilograms, meters per second squared, divided by meters. Well, it's newtons per meter. Kilogram, yeah, there we go. So, per meter. Kilogram meter per second squared is a newton divided by a newton. So that's a place to be careful because for a minute it looked like the dimensional analysis was not working.
Oh, snap. That's pretty cool.
So, units? Awesome. Okay. How many sig figs? 2. So K equals 270 newtons per meter. Did they get it right? They did. Okay, you are assigned numbers 1 through 4 on page 441.